Let us understand the arrangement of wheel and differential axle. In this case, axle with diameter d1 and d2 and wheel with diameter capital D are fitted coaxially. There are two ropes used. One rope is connected to the axle with diameter d1 and d2 and other rope is connected to the wheel with diameter capital D. Now we will understand how these ropes are mounted on axle as well as wheel. So we will take one end of the rope. Now it is connected to the axle with diameter d1. So I will show here the connection. So here this rope is connected. Now we have to take the other end, that it should form a loop, and then we have to connect the other end to the axle with diameter d2. So I will show this. Here is the other end. Now if we observe, for this loop we have to place the pulley, and this pulley should lift the weight. So we will apply the load at the end of this pulley. So this load is FLE. Now what is the direction of mounting? We have to mount these two ropes in the opposite direction. Now the direction of mounting for the axle with diameter d1, suppose in this direction, then the direction of mounting of the axle with diameter d2 is in the opposite direction. Now here the one rope is used. Now we will move for the other rope. Now this rope we have to mount on this wheel. So how it is mounted? We have to mount in the same direction of the axle with diameter d1. So here if we observe, with diameter d1, this is the direction we have to use, and we have to mount the rope. So I will show here. So around this wheel we have to apply this rope, and here effort FE is applied at the end of the other end of the rope. So here is the direction of mounting. So if we observe, direction of this mounting is same for the wheel as well as axle with diameter d1, and the opposite direction is for diameter d2. Now for one complete revolution, what is the distance moved by wheel due to effort? So here is the effort FE applied. So if we apply the effort, then what is the distance moved by the rope? That is equal to perimeter of this wheel, that is equal to pi into d. So I will write here pi into capital D. Now the one complete revolution, there is also one complete revolution of this axle for with diameter d2 as well as d1. So for length of winding rope with d2, so we can say that when one complete revolution, there is winding of the rope for the axle with diameter d2, that is equal to pi d2. Now we know that this rope is mounted in opposite direction. So when this rope is winding around the axle with diameter d2, at the same time this rope will unwind. So length of unwinding rope with diameter d1, so it is equal to pi d1. Now if we observe, for this both d2 and d1, both are in opposite direction. Now we know that d2 is greater than d1, so I will write here d2 is greater than d1. Now d2 is winding, d2 is having winding effect, and this d1 is having unwinding effect. So what is the net effect? So if we observe d2 is greater than d1, so what is the net effect? Net effect is winding, and we have to find out the net wound length. So how to find out? Both are in the opposite direction, so we will give here negative sign. So both net wound length is equal to pi d2 minus pi d1. So we will simplify this pi d2 minus d1. Now we know that this pulley is connected in between these two ropes, that is in between this winding and unwinding, and the load is also connected. So when there is net wound effect, then at the same time when it is getting wound with diameter d2, rope is getting wound, then this load will be lifted, or we can say pulley will be lifted. So I will show here the lifting of pulley. But this pulley is placed in between these two ropes. So what is the total height for which pulley is lifted? That is equal to net wound length divided by 2. Because in between these two ropes there is the load is placed. So I will write total height for which pulley lifted pi d2 minus d1 divided by 2. So that is the total length for which load is lifted. Then what is this distance moved by wheel due to effort? That is equal to pi d. So how to write the velocity ratio? So we know that velocity ratio is equal to ratio of distance moved by effort to the distance moved by load. So we can write here distance moved due to effort is pi d divided by distance moved by the load is equal to pi d2 minus d1 divided by 2. Now this pi is getting cancelled, so final formula for VR is 2d divided by d2 minus d1. So this is the formula we have to use for the velocity ratio for wheel and differential axle.
Given question, a load of 15 kN is to be lifted by a differential wheel and axle. It consists of differential axle of 250 mm and 300 mm diameter, and the wheel diameter is 800 mm. Find the effort required if the efficiency of machine is 55%.
Let us understand the given data. Diameters of the differential axle is given 300 mm and 250 mm. Now if we observe this diagram, D2 is greater than D1. So D2 is equal to 300 mm and D1 is equal to 250 mm. Diameter of wheel, that is capital D, is equal to 800 mm. Now from this data we will calculate velocity ratio. It is equal to 2 into capital D divided by D2 minus D1, and which is equal to 32. Now efficiency of the system is given 55%, and we have to find out this applied effort Fe, where load is given 15 kN. So we will first calculate mechanical advantage, because mechanical advantage is the ratio of this load to the effort. So neta is equal to, efficiency is equal to mechanical advantage by VR. So 0.55, because 55%, that means 55 by 100, that is 0.55 is equal to MA by 32, where mechanical advantage is equal to 17.6. So FL by FE is equal to 17.6. Now this load is given in kilonewton, so we will convert it into Newton. So effort Fe is equal to 15,000 divided by 17.6, which is equal to 852.2 Newton.